Yeah, kind of for work. It's something I've been learning for a couple of weeks now, and I've been really impressed. So anyway, welcome to the Tyler Web Dev for August 30th. This is going to be a screencast regarding Travis CI and continuous integration. So I wanted to talk a little bit about just the idea of continuous integration in general. This is a concept where if you have a team of developers or even as a solo developer, you might have the need to integrate your project and your work amongst your team with in a single server and be able to quickly validate that your project is functional and passing tests. And if you choose to do so, you can also add continuous deployment. Also, TravisCI supports that. So I'm going to kind of just do some examples of what I've been playing with probably for a few weeks now, and I've been really impressed with just the capabilities. I had no idea about just the robustness of what TravisCI offered. So I've got a lot of stuff kind of pre-set up because most of what I want to cover here is not going to be super important, but I'm just going to go. I want to show you what I have already, and then we'll talk about adding the continuous integration piece on top of an existing project. So just to kind of simulate this, I've launched a CentOS server in Amazon EC2. They also have Lightsail now, which you might find easier if you're trying to do just a cheap development option. But EC2 is what I was familiar with, so I've launched a server here. This will be our web server, and I'm also going to use it for running the Travis command line tools because it sometimes is a little flaky on Windows with some of the things that I need to do. So I'm kind of using it for two different things. And I've got a little project running on my computer here. It's a cold box project, which isn't really important to what we're covering, but it's just to show the idea of a little web app. I basically just have the empty shell project here. I've not really customized it or add really any custom code. I do have it to where my tests are running, so I'm going to show over here in my command box environment. Let's see, I may need to, yeah, so we've got passing tests. And so the idea is that, you might start this way where you build an application locally, you even write tests and you get those running locally. And now you need to integrate with other developers and you want to have a common source of the status of the project and make sure that everything's building cleanly, tests are passing, and being able to update a staging server without any manual intervention, totally automatic process. So that's kind of what I'm wanting to show here is how to take a project that I've got running just locally on my computer and kind of getting that published out. Now I've already set up the server. I've already set up the staging server that I want to publish to. I just created this little domain for it and everything's pushed out here. It's working no problem or whatever. But the only way I have to deploy to it right now is by just using an FTP program. So I've got my FileZilla here. I can upload. That's working fine, but it can be kind of tedious if every time you need to push something out to the staging environment, you have to, pick out the files or upload your whole project, which can be kind of can be kind of a lot sometimes. So again, I'm using a cold box project, but any type of language could be used here, PHP, Node, whatever. The principles are going to apply across the board. So see if there's anything else in the pre-demo setup. Okay, yeah, I wanted to show what I did. So I started up the CentOS server and I installed a few packages here. I can kind of go back in my history. I just did it in this shell right here, so you can kind of see what I did. I had to install Ruby because I'm wanting to install the Travis CLI client, which is a Ruby-based application. I hit one snag because the server was such a vanilla server. It didn't even have like GCC installed. So I basically had to install Ruby, Ruby, Devil, GCC, and then I was able to install Travis and get logged into Travis. So that's kind of where it's at right now. If I do Travis-V, I can see I've got, showing the version number, so that's working. And I already did a Travis login. I'm using Pro here. Actually, I probably need to do a non-Pro login. I didn't think about that. Okay, let me go back to here. I realized earlier I had done a Travis login -- Pro, which was for the commercial. So now I'm re-logging into TravisCI.org, which is the open source side. So I didn't think what I had done earlier was actually going to work. So I'll make that change here. And then I set up Apache, but I ended up not needing that, so I'm not even using Apache here. And then I've created an empty, like the project that you're seeing here, I've created an empty or a shell project, a shell cold box project, and I've got that checked into this GitHub repo, twd-ci. So that's kind of the key element of getting Travis to work, is having a GitHub repo set up for the project. That's how Travis finds your build. As every time you commit to GitHub, it's listening and will automatically trigger the build based on every time you will commit. So I think that's it for the kind of the pre-demo setup. Now we'll kind of really get into the meat of what we need to do. If any of the steps I just breezed over we need to come back to, that's fine. Those are not the important steps that I'm wanting to demo today. Just kind of giving you the background on what's set up so far. So the first thing to get started with Travis, TravisCI, which just stands for continuous integration. There's a lot of projects out there. There's other platforms you can use, Jenkins, and we use Cruise Control some at work. I mean, there's different platforms. So if you go to TravisCI.org, they've kind of done it sort of clever here, where if you go to .org, it's the open source free version of TravisCI. And if you go to TravisCI.com, you're looking at the commercial version of TravisCI, which is essentially the exact same platform. The only difference that I've even encountered so far is that TravisCI.org, of course, is free, and it will pull in, it'll be able to build any of your public repositories in GitHub. So this would basically be like, anything that is like an open source project or a project that you don't mind, just being publicly available. So like this project that I have right here is, anybody can go to this URL and pull it up. It's a public open source project. And so TravisCI.org will freely allow me to use their platform to run builds and integration with no cost to me. You just log straight into TravisCI with your GitHub credentials. TravisCI.com, on the other hand, works very much the same way, except it gives you access to your private repositories. These would be your proprietary code that would be used for typically commercial purposes. And it does have a monthly fee. I think it starts about $60 a month. And this gives you like one concurrent build. So you can have as many repos using TravisCI and building it or building, but they can only one job can build at a time. So it's a pretty good metric for scaling the pricing. It's a very reasonable limitation. If you do have multiple projects, you can use it. Doesn't matter how many users are committing, but you can only have one job at a time. And so if you need to do more than that, your pricing goes up from there. But otherwise, the platform is very identical between the org and the com sites. So I'm going to log in now to the TravisCI.org, which I'm actually already in here. So you can click on your user here to get to the list of and sync. Either you can hit this button if you need to, the sync account. What this does is it goes to GitHub and pulls in your public repositories. And saying right here, you can find your private repositories on TravisCI.com. So again, that's the distinction between org and com, public versus private. So these are all my public repositories that are in my GitHub account, and I can just flip on the the integration, the CI build, just using this little toggle that's out here. So I think I'll do that next. I think that's the next step. And as soon as you do that, you've sort of started the basic process. There's almost, I think that'll even actually start triggering a build, even without me doing anything else other than just committing to my normal repo. So let's go back to the list of repositories here. See where that's at. Maybe it's if I click on this. Yeah. Okay. So you can kind of see the repositories that I have. They're all pretty much test repositories for what I'm doing. Here's the one I'm just working with for today. There's been no builds because I haven't even committed once since I've turned it on. So what I'll do right now, let me do this real quick though. I wanted to point out one thing that toggle would do. Okay, I wasn't sure. I thought that might put a build button out here, but you might have to stick that into your README. I thought that was automatic. But anyway, you'll see this little icon up here will also appear in your GitHub repository once it's building. So to see if we can trigger the build, and some of this stuff is, still a little bit new to me. So some of these things I'm still trying to completely figure out. But let's say we wanted to, so I'm in that project, I'm in that TWD-CI project, and really it's kind of agnostic to what file you're committing. So I believe, so I'm going to go ahead and, do some customization of this README file here. And I'll commit that using Git Kraken. We'll stage that. So I just made a kind of a non-important change here. Make my commit, push it out, and I believe that just by pushing, it should trigger that build since we flipped on the toggle for it. Yeah, you can see I didn't do anything to configure it. It just now recognizes that a new commit's come in and been pushed to GitHub, and so it doesn't even really know what to do because it's not able to. This is a Cold Fusion project or a Coldbox project, and so it doesn't really have any knowledge of like what it needs to build. I'm not even sure what it'll auto detect as. So, but it's trying. It's checking out the project here, and let's see what it does, if anything. What's nice about Travis is every time you start a build, it fires up a Linux instance, either a virtual machine or a Docker instance, and execute and builds your dev environment from scratch. If there's any packages you need to install or any configuration you need to do, and that's kind of the thing I'm wanting to show tonight, is the configuration necessary to kind of get some of this stuff working. So let's see, what did it do? Yeah, so it just defaulted to a Ruby project, which this isn't a Ruby project at all. It didn't find a rake file, and so it just failed because it didn't have enough information to know what to do. So we can kind of start tweaking that a little bit. The first thing we can do is create a travis.yaml file. So it's .travis .yaml. I think that's right. Make sure I get that right. Yeah, .travis.yaml or .yml, sorry, but it stands for YAML. And I'm just gonna put a small amount of configuration in here and copy from my pre-built here. And I'll cover more about what all this is here in a minute. Okay. One thing you'll have to be familiar with when you work with YAML format is all the indentation and spacing and punctuation is very particular. So it has to be pretty much exactly like it's shown here. Let me put this space in because that won't work without it. So what I've created here is like a bare bones Travis configuration file. And so the distrusty is the name of the Ubuntu flavor that will be run. So that tells you what version of Ubuntu. The sudo false tells it to run as a container versus as a VM. Language Java just tells it what platform it is, and then this JDK tells it to make sure that the Oracle JDK 8 is installed. So when I commit this, let's see what happens. Okay, so now we'll just flip back to our build environment, and you can see, I mean, you can barely get back to it before it's already started working, and that's been pretty typical. There's been some times where it's kind of gotten stuck and the build's been super slow for some reason, but generally it's very, very quick, and especially if you use the container-based build environment, which is that sudo :false that I put in. You can kind of see my config here, sort of imports it. That sudo false tells it to use a Docker container environment. So this still failed, but it went kind of a different direction. And rather than trying to build as a Ruby project, since I told it now it's a Java project, which isn't purely true. I mean, it's a Cold Fusion based project, but it is based on Java. So that's probably the best build environment for what we're going to be needing to do. Some of the things we'll need will require Java. So what it did to try, it's just guessing based on the language that the most default or conventional test thing that it needs to run is ant test. So that's the ant build system and the test project. And well, again, we don't have a build XML. We're not really using that type of format, but you can see that it's just trying to choose good defaults based on the information it does have. So I'm going to continue to build out my my Travis YAML file here. I'll add a little bit more information. Let's see if I can get down to this point. I'll cover this stuff. So the cache, this isn't super important. This is just some stuff. What we're going to use for testing this Cold Fusion project is a command line environment called Command Box. And so this is a little package management tool as well as a command line tool for managing Cold Fusion servers. And so, again, you start with a vanilla empty build environment, and you can pull in any type of package that you want, including, in this case, we're going to actually be downloading Command Box directly from this URL, unzipping it, and then running it right away. Normally, you can the command box publishers actually provide yum packages and deb packages, but there's some weirdness in the way apt-get works. Normally, you'd be able to just do apt-get command box, but without going into all the details, it wasn't able to work here. So this approach was fine. I just manually downloaded the zip using wget. It's being output to /temp/command box and being unzipped just right in my project, in my build directory. So, and you can start to see the beginning of this kind of life cycle that a Travis build goes through. There's, before install, before script, after script. There's all these little hooks into different parts of the build, and you can say, for this step, do these things. And so for the before install step, I'm going to continue to install my dependencies, which in my case here is getting command box installed and ready to be used in the install step. The install in this case is box install, which tells command box binary to read my box JSON of my project and install the dependencies. This could also be a composer install. This could be an npm install or a yarn install or something like that. Again, this is just a Cold Fusion kind of specific, but the idea is the same regardless of what language you're using. It would just be a slightly different command appropriate for that language. Same concept though. And I went ahead and put in this for script. Script is like the main thing of the build. This is the thing that's supposed to trigger the build, and what Travis is going to base the success or failure of the script phase is kind of the success or failure of the overall build. And so what I'm doing here is saying script true, which just means it's always successful. It didn't actually try to build anything. What we're really wanting to do is we're building up our build process here, and is verify that can we get command box installed okay, or if you were doing PHP, it would be Composer, and make sure that we can do a box install. This is just to validate that the build environment is coming up clean before we actually try to run any tests or anything. So some other stuff, just what I got copied in, notifications, false, email false. So it just by default, it's going to email you whether it's succeeding or failing. You probably will want some sort of notification enabled in a more real world environment. This add-on, this is really for later. I'll come back to the add-ons, the SSH node host add-on a little bit later. So let's try this. This is kind of the next milestone, and we'll see if command box can get installed successfully here. So again, I'm just making changes to that Travis YAML file and just continuing to commit it. Added command box. I'm going to push this out and flip back to our build environment, and it'll probably kick off on its own here just in a second. You can look at the build history at any point and see what's been so far. The first 2 builds have failed. Hopefully this one will succeed. This will be the first one to succeed if everything's set up correctly. So I always hit this little circle over here that says to follow log, and this just keeps your browsers scroll with the output that's coming, so you're kind of following along the terminal. Okay, so it's checking out the project. Let's see, did it? Okay, I think the next step is going to be to install or download. Oh, there it's installing Java. It's getting that set up. Now it downloaded command box successfully. It unzipped it. Now it's running box install, which really for this project, there's not a lot to it. It's just the cold box package and the test box package are the only 2 dependencies that box install will need to pull in. So fortunately, some of this stuff will be cached. The bulk of your stuff is wiped away on each new build, but that's part of what I have up here is some of my options with the cache directories. I'm able to preserve the actual command box installation to some degree. I don't fully understand how it's caching, but it will speed up in future builds after this first one. So says libraries initialized, and that may be the end of the build. It sometimes doesn't output much. Okay, it's going a little further. Okay, there's pulling in cold box and test box. And then you see this one line that says true. Well, that was our entire build script, and so that just tells the system everything was fine. And it says done. Your build exited with 0, so the whole build overall has succeeded. And let's scroll way back up here. I get a green on our build this time. So the next step that I'm wanting to do, I've got my package management tools installed. The install is working. Now what I want to do is see if I can run some tests, which I haven't really been doing too much of this in my production work, but I think I have the right information here to do it. So I'll paste this in and explain a little bit more about what's happening. Whoop, not that. Copy. Okay. So I've added another lifecycle hook here before script, and what this is saying is to run. Maybe I need to do I don't know. Do /box server start port 8500. So what this is going to do is fire up a little Lucy instance. Lucy is the open source Fusion server that I'm using here, and just tell it to start on port 8500. It's really pretty arbitrary, but I need to know what the port number is so that in my script statement here, I can tell it what URL to call. So it's actually going to fire up the cold box server, or the Lucy server that'll run my application, and then it'll run this test box command, which is a command box command, and give it these parameters, and it's going to call the runner, and it should give me the same output that I'm seeing in my shell over here if I was just running tests locally. When I do test box run, it runs my tests, I'm going to be doing the same thing, but I'm going to be doing it automatically. And this is really the core of what continuous integration really offers you, is automatic test execution and feedback, quick feedback. This way, if your changes that you just committed broke something else or someone else broke your changes, you can be notified, and it just kind of lets everyone have a central communication as to what this current status of the project is. Hey, something needs to be fixed, or whatever you just did, put it in an unstable state. And so this is really kind of one of the core features that we get out of this. So let's hope that this runs. Now I'm going to delete my other script statement. I'm not going to do script true anymore because I'm actually going to want the build to succeed or fail based on my test success. So save that and commit it. That's one thing you'll notice when you're having to develop a build process. You end up making very many commits because that's really the way to test it. You can get the Travis command line environment, and I'll show some of that here in a minute, but mostly I've just kind of been doing it this way, where I just commit each change and see what effect takes place in the web UI. So let's add test runner script and push that out. And take a look at the build. Okay, it's already off to the races here. Okay, let's do the follow. And I really feel like I just have to iterate. Like it seems to be going really fast here. I mean, this is basically is just as quick as I push the file. Within 5 seconds, the build's been triggering, and it may be time of day. It may not always be quite that fast, and again, especially if you don't use the container-based, and depending on what your project requires, if you have to install a lot of dependencies, this one's running in about a minute or less. If you have to install a lot of dependencies, or your tests take a while, or whatever, the build could run 4 or 5 minutes. One thing that's nice about Travis is it actually offers different build environments, any type of Linux environment, but it also offers Mac OS X environment. So if you did need to build something that only compiled with Xcode or something like that, they totally have the capabilities to do that, which is really interesting for mobile development or Mac OS development or whatever. They actually have the options for that. So I've not used it yet, but that seems like a very useful thing for that type of development. So it's made it to the testing step. I don't know if it's going to succeed or not. It looks like it started the server, and it takes a few seconds for the server to come up. So I hope that doesn't. Hope there's not a race condition between starting the server and running the tests. Let's see. No, it says 8 passed. So the test ran, and all 8 tests passed in about 10 seconds. And I think it looks like it succeeded. Which is great. I hadn't done it that particular way before. What I'm going to do now, just to demonstrate kind of the usefulness, is I'm going to try to break one of the tests. So again, I don't want to get too many of the details that aren't relevant to what I'm talking about here, but just to kind of show you my test, this is using a test box testing tool, and I've got my spec file here. Again, this was all kind of boilerplate code that came with creating the shell project. So right now it's expecting, when I call this main index event, to see the text "welcome to ColdBox" in a variable called welcome message. All that's not too important, but what I want to do is change the value. Like, so say I thought, well, I don't want to say welcome to ColdBox, I want to say welcome to Tyler Web Dev. And I think, okay, that's a good change, because now when I go out here and look at my project, see what it says. Okay, it says welcome to TWD. Okay, that's what I wanted. Now I know that that's going to break my test. So I could, if I verified it, I could say, oh, I've got to go fix that test. But say I didn't do that step, maybe for whatever reason, or there could be any number of reasons that something you commit might break some tests. I can see clearly here, but I'm going to go ahead and commit it this way and see if Travis can also help me recognize that there's a problem. So I'm going to commit this file that I just changed. So this is more of a real example of how like Travis would be used on a day-to-day basis, actually changing code. So fixed or updated welcome message. So I'm going to push that out there. This time I didn't change the Travis YAML file at all. This is just a purely code change. Okay, it's taking a second to push. There it goes. So we'll go back and see what happens in our build process this time. It's already building. And another thing I really like with the build history is, all this activity could be happening over the course of many days or weeks or whatever, and you can come back and look directly at the builds that were completed in the past and see, well, what happened? What was failing at this point? Or why did it work then? What did I change? It's going to be tied right into the commit that generated right here. I can view the commit, what code was changed. Look at this on GitHub and see, oh, okay, we added all this, code, and that's what caused the build to go from not working to working. Or, in this case, you can see it just failed. I could go in here and say, well, what was that? What caused that to fail? I could look real quickly, and because I only changed one line of code, it's pretty obvious something there caused the build to fail. So you've got that history, and that'll be there, I guess, indefinitely. So you can go back for days or weeks or whatever and see how things have been running. And so, okay, so I've been communicating. Again, I would get an email notification. I might get a Slack notification. Any kind of there's any kind of notification you can imagine to when a build fails, as you want. And so I'd get this notification saying, hey, you updated the welcome message, but the build failed. I could come back and look at the log, and I could see here, oh, okay, one of my tests failed. And then I could go back and fix and realize I'd run my test locally, sure enough, failing. And then say, oh, I did want to make that change. I did want it to be called welcome to TWD. So what I need to do now is update my test to match the assertion, to match what I changed it to. So I'm going to say welcome to TWD here. Let's save this and stage it and say updated test for new welcome message, which is pretty common with a more test-driven approach to development. You often will have to go and adjust your test as things change because they no longer are asserting the right thing. So now I introduced a problem, Travis found it, and now I'm going to go fix the test because of what I wanted. Now, the opposite could have been true too. I could have actually broken something and I need to go fix the code. It was the code that was wrong and not the test. In this case, it was the test that we forgot to update. And so that's what I changed here. So we'll go out here. It's like it's already building. Again, I just love how fast it kicks off. I mean, there's just, I can't get back to the screen fast enough before it's already triggered the build. So that's really been very impressive. Okay, so it's building. Hopefully it'll get it right this time, and our change will have been caught and fixed, and we'll be back into the green state. So let's follow the log here. And pretty much anything you could do on a Linux server or Linux environment, you can do in here. Anything you need to install, anything you need to configure, you just script it all out through Travis, and you've got a very dependable, very reliable, builds the same way every time. So it's a great use of this technology. Okay, so it's running the test. Hopefully that'll succeed this time. And again, most of the time you don't sit here and stare at the build each time. It's something that's usually can be more passive. You just commit and go on about your business and only look into this whenever there's been a failure. So, ideally a large chunk of the time, you're going to commit, it's going to do this thing and it's going to succeed, and you're not going to have to like come back and interact with it normally. This is just so we're interested in what it's doing right now. So again, now the build succeeded, so we fixed that change. I think I kind of wanted to point out here, this is all you kind of took away from this like discussion, this is kind of you've got a lot of mileage out of just this piece. We pull up the Travis file as is. So this is where most people are. This could be all you do with Travis, and still it'd be worth its money here. But I want to. The next thing I want to do is show how you could automate your deployment. So this is automatic testing on each commit. I want to show how you could also auto deploy the project to a server on each commit, assuming the build has succeeded. And so that's what I'm going to show now. I'm going to pause the video just so I can split it up, and we'll have two separate videos here. So join me in part 2 if you want to see how to do automatic deployment.